welcome. So this is one of these circumstances where we can actually show you mathematically why something makes sense or is true, just using actually the calculus that you've already learned. So this is kind of a nice thing to actually do. And what we're going to do is we're going to do this part of the p-test. Okay, so we're assuming that, a should be greater than 0. And then we have that we're taking the integral from 0 to a of dx over x to the p, and we're going to actually get that it diverges when p is greater than or equal to 1, and we get this value, so it converges if p is less than 1. So let's just kind of go through the different circumstances. So let's first look at the circumstance where p equals 1. Okay, so in this circumstance, we have the integral from 0 to a of dx over x to the p. Right, but we're saying that p equals 1, so this is just going to equal the integral from 0 to a of dx over x. Okay, but, so this is going to be the limit as t goes to 0 from the right-hand side of, and then we have the integral from t to a of, and then we have dx over x. Okay, but this is equal to the limit as t goes to 0 from the right-hand side of, and we're going to get, so we're going to get the natural log of a, because this is greater than 0, I don't need the absolute value, minus the natural log of t. Okay, but t is approaching 0. In order for t to approach 0, this actually has to approach minus infinity. Okay, so that's actually going to give us that this equals plus infinity, because we have a minus minus infinity, and this is a finite number. Okay, so this diverges. Okay, so now let's look at the circumstance where p does not equal 1. Okay, and I'll do kind of the general thing, and then I'll break it into when p is greater than 1 and less than 1. Okay, so if p does not equal 1, then what do we have? We have that the integral from 0 to a is going to equal, so we have 1 over x to the p dx. Okay, it's going to equal the limit as t approaches, right, so we're going to approach 0 from the right-hand side. So we go t to a of, and then I have 1 over, it's the same thing here. So in this case, I just changed it to be a limit. So that's nothing that exciting. And then what this is actually going to equal, right, so this is the same thing as minus p, or sorry, x to the minus p. So this is going to equal the limit as t approaches 0 from the right-hand side of the integral from t to the a of x to the minus p. Just makes it a little easier to compute when we write it like that, which is going to equal the limit as t approaches 0 from the right-hand side of x to the minus p plus 1 over minus p plus 1 from t to a, okay, which is going to equal the limit as t approaches 0 from the right-hand side of, and then I have here a to the 1 minus p, and then I need to divide that by 1 minus p, okay, minus, right, so I just put in my a. I didn't kind of do this like I normally would. So notice, so the first thing here to notice, so this is the same thing as 1 minus p, okay. I was getting a little carried away. I didn't put my parentheses like I normally would. So this would be 1 minus p over 1 minus p, and then I would put in, so I put in my a, now I'm going to put in my t. Okay. And so this is what we're going to use in the next two. So we have that there. So using that, let's break in the two circumstances. So the first one is where p is greater than 1. Okay. So if p is greater than 1, then we're going to get, well, we're taking the limit as t approaches 0 from the right-hand side of this thing. So we have a to the 1 minus p divided by 1 minus p minus t to the 1 minus p over 1 minus p. Okay, but p is greater than 1. Okay, and so that's actually going to tell me that this is going to go to infinity. Okay, so this one has nothing to do, this is just finite. Okay, so this is finite. And this thing here is going to go to infinity. Okay, and so this is going to be positive infinity, or is going to diverge. Oops, this is going to go to negative infinity. Wait, negative. Oh, I see. No, it's positive. The tricky part that's in here. So this part is positive, but this part is negative. So maybe say minus infinity, with the tricky part being that this is less than 0. Okay. Great. And then, right, so this is less than 0. So that's also something to keep in mind, is that we're getting like 1 over, that's actually a little complicated. Maybe I won't go into that in this one. But you can ask me in office hours if you'd like to go through that, or try to go through that carefully and think through what's true here in terms of, so this is less than 0, so we've got t to a negative power, so it's like having 1 over t, but t is actually approaching 0. Okay, that's kind of what's actually going on. Now let's say that p is less than 1. Then we're going to have that the limit as t approaches 0 from the right-hand side is going to give us, so we have a to the 1 minus p divided by 1 minus p minus t to the 1 minus p divided by 1 minus p. Okay, but now we have that p is less than 1, okay, which is actually going to end up meaning, so this stays positive, but we're approaching 0, so this whole thing actually goes to 0, which is going to give us that this is going to equal a to the 1 minus p divided by 1 minus p. And this converges. Okay, which is exactly what we knew was going to be true. Okay, so I hope that makes some sense, and I will see you in the next lecture.